We are official. So, I know we've already talked about exponent rules, but there are a few more that we haven't talked about, okay, for the exponent rules. Actually, really only two as far as I think, so far I can remember right now. But maybe I'll teach both of them. Now, why not?
We just do one, so it's not as hard.
Okay, we'll just do one. We'll just do one.
Yeah.
All right, so this is it. And it's a weird one. This is a very, very weird rule. But once you understand it, it makes sense. And don't make it harder than it is. But if I have x to the negative n, that is the same thing as 1 over x to the positive n. And now notice what happened is the sign of the exponent is negative here. The sign of the exponent is positive here. Now, let me explain. Let me just give you an example of where this might come up, right, in real life. Or not real life, but in a problem. Let's say, remember this rule where, x to the n, m over x to the n is equal to, same bases, x to the base, and then m minus n. Remember that rule? Yeah. Okay, so what if I had this? X to the 4 over x to the 9. Would that be x to the 4 minus 9? Am I right? Yeah. 4 minus 9, which is what?
Negative 5.
X to the negative 5. Now, it is legal to have negative exponents. It's totally legal. But it's not legal to have your final answer be with a negative exponent. That's the only thing that's illegal with negative exponents. Your final answer must always be in with a positive exponent. So if you got x to the negative 5, up to this point that's what you got, and you got it right. And I said it was right. But now you have to go one step further just because it's the final answer, right? Does it make sense? So that one step further is this. 1 over x to the positive 5. You with me? Now, let me explain this a little further over here. Let's try this. Watch this. I'm going to do this. I'm going to actually do this long form. What does x to the 4th mean?
X times x.
Right. Okay. So we've got x times x times x times x, right? That's x to the 4th over x to the 9. X times x times x times x times 1, 2, 3, 4, 5. Did I do that right? Okay. Okay, you guys agree with me? This is the same as that? Yeah. For sure? What is x over x equal?
1.
Oh, so I could cross those two out. What is x over x equal? Oh, so I could cross those out. What is x over x equal? Oh, so I could cross that out. What's x over x equal? 1. Okay, I crossed that out. What's left up here? Well, think about it. When I crossed these out, what did I do? I said x divided by x is 1, 1, 1, 1, 1, 1, 1, 1. So really, it's just 1 times 1 times 1, so it's 1, right? Upstairs, I have 1. Upstairs, I have 1. What do I have downstairs? X to the 1, 2, 3, 4, 5. X to the 5th. So look at that. We got the same answer. This time, though, I didn't get x to the negative 5. I got just 1 over x to the 5. So when you do it the long way, it does. I mean, it crosses things out. But these are shortcut rules, right? They're ways to kind of move kind of more quickly so that you don't have to do this. I mean, because if I gave you, x to the 417th over, x to the 645, that would be a real bummer if you were doing it this way, right? It would be a real bummer. So it helps to know these shortcuts. That, oh yes, same bases. If I'm dividing, then I subtract the exponent. Same bases, and then I have 417 minus 645, whatever that is, and then I've got my answer, right? But it's negative, and then I have to put it in this format. Does that make sense? You see that? Now, let me just show you how this practically works. Whenever you, this is actually really important. Whenever you have a negative exponent, you can make it positive by moving it and its base across the, I know this is long, but this is the last word, fraction line. This is gold. This is gold. If you understand this, it will make this so much easier. We didn't talk about this, I don't believe.
Oh, I think you
I might have talked to you about it or something, but I didn't actually teach it formally. But so what that means is this. See how this, well, let's just do this. Let's say I have x to the negative 5, right? X to the negative 5. It says here, whenever you have a negative exponent, which I do, I can make it positive by moving it across the fraction line. Wait, what fraction line? Is there a fraction line here? Could I create one?
Yeah.
How? Over 1. Right, now it's a fraction, right? What is the number in front of the x that's hidden? You guys all agree with me? Agree that there is a 1 up here, right? Now, what does the negative 5 exponent affect? Does it affect the 1 or just the x? It only affects what it's next to. It's next to an x. It would affect the 1 if I had a parenthesis, but it doesn't, I don't have parentheses. It affects just the x. So what happens is, if I want to make that positive, I just have to circle it and move it downstairs. So I leave the 1 upstairs and I have x to the 5 downstairs. Did you see what I did?
Oh, yeah.
All I did was move it across this fraction line, boom, and it becomes positive exponent. It's as simple as that. If I wanted to make this a negative exponent, I'd move it back up again. It would be x to the negative 5. Right? See what I'm saying? So if I did this,
No.
Yeah, Gary, I didn't write that down.
I was so close. I have it.
okay, so read it. Just read it. I'm sorry.
Whenever you have a negative exponent, you can make it positive by moving it and its base across the fraction line.
Sorry about that. Well, what if I showed you this? X to the negative 2, y to the negative 7 over a to the negative 1 and b to the negative 10.
Just kind of like switch
And
it.
yeah, so if I wanted to write this in proper format, what would I do?
Just
I would move this one and this one downstairs, right? And I would move these upstairs. So I would have a to the positive 1, b to the positive 10 over x to the positive 2, y to the positive 7. It's as simple as that. I just move these downstairs. By taking it across the fraction line, the signs become positive. When I move these up, these were in the denominator, they were negative. I put it across the fraction line, and they became positive. Does that make sense?
If there is something like the A, would you have to put A to the?
You don't have to put a to the 1. You can just put a. Good question. Yeah, either this one. Does that make sense? So that's basically how you do it. So if there is a fraction already, then just move it across the fraction line. Either down if it's upstairs, or up if it's downstairs. If there isn't a fraction line, make a fraction line, put it over 1, and then move it down. Now what if I gave you this though? What if I gave you this? 3x to the negative 2, and you had to simplify that with positive exponents. First of all, there's no fraction line. So what do I do? Create one, right? You with me? What does the negative 2 affect? Does it affect the 3? No.
The one.
So I'm just going to circle the base and the negative 2. I now know that goes down, the 3 stays up. You get me? 3 over x to the positive 2. Yes? Right? How about this one? We'll just do a bunch. 5x to the negative 8. What would it be?
It'll be 5 over x 8.
You got it. Yes? Just a 5, you guys get it? Makes sense to you? Awesome. Okay, so we're almost done. Now, I just want to show you one other thing where you're likely to see this. When you use distributive property. Remember what distributive property is? If I said 2 times x plus 4, what would that be?
2x plus 8.
Right? So 2 times x is 2x. 2 times 4 is plus 8. What if I did this though? 2x times x plus 4. Now I've got not only the 2 times this, but I've got an x times x. What is x times x? X to the 1 times x to the 1 is equal to x to the 1 plus 1. You with me? Does that make sense? So, okay, 2x times x plus 8x. But what is x times x? X to the 1, aren't those same bases? So couldn't I say x squared?
Yeah.
Right? So that is 2x squared plus 8x. And that's as far as you can go. Let's try another one. Let's try 3x squared times, well actually let's just try, well, let's just keep it simple for a second. 3x times 2x plus 1. 3 times 2, I've got to do this whole thing times this, and then this whole thing times this. So that's 3 times 2 is what?
6.
And then x times x, x squared. So 6x squared plus 1 times 3x. 3x, right? Yes? Make sense? Okay, let's try a harder one. How about 4x to the 5th times x squared minus 5?
Wouldn't you do the 4x to the fifth first? Like,
Yes, so I'm going to do this times this. So that equals 4. If you need to, you can do it in 2 steps. 4 to the 5th times x to the, x to the 5th times x to the 2nd minus 5 times 4 is 20, 20x to the 5th. Now, same bases, right? So what could I rewrite that as?
Adding
4x to the
7.
4x to the 7th. Beautiful. 4x to the 7th minus 20x to the 5th. Okay? So that homework's going to involve both of these rules. This, doing the first page is distributive property. The second page is practicing your negative exponents. Okay? So it's pretty targeted just on this. Okay. So can I stop this?
No.
I won't erase. I'll stop.